November 15, 2014. The DuPont facility in Porte, Texas. 4 workers were killed and 3 were injured during a large release of highly toxic methyl mercaptan within the plant's insecticide processing unit. The sequence of events that led to the incident at DuPont began on Monday, November 10th, when the plant's lannate unit was shut down due to a problem with a reactor. Within that unit, methyl mercaptan reacts with other chemicals to create the insecticide lannate. By noon on Wednesday, November 12th, operators attempted to restart the unit. However, the startup was unsuccessful because piping within the reaction system was blocked. This blockage was common following a shutdown and was caused by a slurry that formed in the pipes from a reaction between methyl mercaptan and other chemicals. To clear the slurry, operators flushed hot water through the blocked piping. By noon on Thursday, November 13th, operators determined that the initial blockage was cleared. But during the operation to remove the blockage, a valve was inadvertently left open that should have prevented hot water from flowing into other piping, known as the methyl mercaptan feed line. The feed line connected the reactor system to a methyl mercaptan storage tank. Operators later discovered that approximately 2,000 pounds of water had escaped through the open valve into the feed line and back into the tank. And the water mixed with methyl mercaptan in the feed line, creating a new blockage that would cause more problems. Since temperatures in the Houston area had been consistently cold that week, the water and methyl mercaptan mixture formed a solid material called a hydrate, which blocked the piping. By Friday, November 14th, DuPont personnel were aware of the hydrate, and a group of operations management and technical personnel developed a strategy to address the problem. They decided to run hot water directly on the blocked piping by placing hoses under the pipe's insulation, heating the methyl mercaptan feed line to above 52 degrees Fahrenheit, enough to transform the solid hydrate back to liquid methyl mercaptan and water. Along the methyl mercaptan feed line, there were 3 locations where it was connected by valves to a vent header, or piping intended to remove excess or unwanted vapor from the process. DuPont personnel used pressure gauges at those 3 valves to determine where the blockage was and what progress they were making to clear it. They also knew that when heated, methyl mercaptan can expand and would need a safe place to vent to avoid overpressure of the feed line. Because the unit was shut down, an additional valve between the feed line and the reactor system was closed, preventing methyl mercaptan from entering the reactors while they were not running. As a result, in this configuration, the only place for liquid methyl mercaptan to potentially flow would be into the vent header, where it was never meant to be. However, DuPont personnel did not consider this hazard when forming their strategy. First, operators cleared the blockage from a section of piping leading from the methyl mercaptan storage tank to a pump that forces methyl mercaptan into the reactor system. Then, operators began working to clear a section between the pump and the closest valve. They cracked open the valve and began to heat the piping to get rid of the hydrate. This caused some methyl mercaptan liquid to vaporize and flow through the valve into the vent header. When this occurred, pressure increased on the nearby gauge. Operators continued this process until the pressure at the first valve stopped increasing, at which point they determined that the blockage in that section of piping was cleared. Hoses were then moved to the next section of the feed line. But as it was nearing the end of the Friday day shift, the hoses were not turned on at that time. At around 6 p.m., the night shift came into work. The day shift supervisor verbally briefed the night supervisor about the strategy developed earlier in the day. The operators turned on the hot water hoses and continued efforts to clear the blockage. By this time, the second valve was fully open. By approximately 1:30 a.m., the operators believed they had succeeded in clearing the piping and attempted to start up the unit. With the methyl mercaptan pump on, They opened the valve between the feed line and the reactor system. However, they found methyl mercaptan was still not flowing to the reactors. The blockage remained, and they once again closed that valve. After the failed startup attempt, the operations crew took a break and went to the control room. But the methyl mercaptan pump was left running. The hot water hoses were still heating the piping, and the second valve to the vent header remained open. Unknown to the operators, at approximately 2:45 a.m., the level in the methyl mercaptan storage tank began to drop. The CSB concluded that at that time, the hot water removed the remaining hydrate, and liquid methyl mercaptan began to flow through the feed line. The methyl mercaptan fed to the system by the pump followed the path of least resistance through the open second valve into the vent header. The vent system quickly filled with liquid methyl mercaptan, where DuPont never expected it to be. The vent system connects the methyl mercaptan storage tank with process equipment inside the Lanate manufacturing building. As liquid flowed into the vent header, pressure began to build within that system. However, high-pressure events within the vent system were not unusual due to flawed equipment design that allowed liquid to accumulate at low points in the system. These events occurred so frequently that DuPont instructed operators to drain liquid from the vent system daily. After the control room operators separately told two co-workers about the pressure problem, they each went to the third floor of the Lanate building. The required response was to drain the vent system of liquid. Two valves were opened, and the unanticipated liquid methyl mercaptan drained into the building, where it readily vaporized, filling the room with a highly toxic gas. Although one of the operators was able to make a distress call, both workers died, unable to escape the building. 4 additional operators responded to the distress call and entered the manufacturing building. 2 of them were brothers. They died together on the 3rd floor of the Lanate building. The 2 other responding operators survived. In total, 4 workers were killed during the release. The release continued for another hour and a half before emergency responders with proper protective gear were able to enter the building and close the valves. DuPont estimated that approximately 24,000 pounds of toxic methyl mercaptan was released.